This is lesson 7-3, all about similar triangles. We have previously gone over ratios and proportions, and then we use that to review similar polygons, how to figure out if polygons are similar, writing proportions, comparing corresponding sides. And so now we're going to kind of hone in our focus and just look at triangles. So 3 different ways you can figure out if triangles are similar are listed here. The first one is AA, similarity. And that's just when 2 angles of one triangle are congruent to 2 angles of another triangle, then you know they're similar. And remember, similar means that the shapes are the same, but we might have either enlarged or decreased it in size. So it's still the same shape, but we either made it bigger or we shrunk it down proportionally, right? But still the angles are all the same size, okay? And I wrote over here for AA similarity, the third angle theorem. If you think back to when we first started talking about triangles this year, one of the postulates or theorems, whatever rules that we learned was the third angle theorem, which said if you're looking at 2 different triangles and 2 of the angles in one triangle are congruent to 2 of the angles in another triangle, then the third angle in both triangles automatically has to be congruent, right? If I have one triangle here and one triangle here, and this is a 60-degree angle and this is a 40-degree angle, and then this one's the same thing and this one's 40, well, we know in all triangles, all 3 angles have to add up to 180. So if this is 60 and 40, that's 100. This third angle automatically has to be 80. Here, same thing. This is 60 and 40, that's 100. So the third guy automatically has to be 80 as well. So once you know 2 of the angles are the same, that means the third one has to be the same as well. So that's kind of what they're saying here with AA similarity. Knowing that 2 angles in one triangle are congruent to 2 in another is enough to say the angles are similar or the triangles are similar because all of the angles are the same size. All right, Sss Similarity. The measures of the corresponding side lengths of 2 triangles are proportional. So if one triangle is bigger than the other, let's say one is 2 times the other size. The first one's double the size of the second one, right? So the proportion would be 2 to 1 or 2 over 1, right? If we compare all 3 corresponding sides from one triangle to the next, the ratio of their sides should be 2 to 1. It should be the same for all the sides. So that's what side similarity is. And then we have side angle side, right? And we're gonna do a little example of that down here. But basically 2 sides, 2 adjacent sides have the same proportions. And then the angle between them is the same size. They're congruent. All right, so let's look at a couple examples and then try a couple on our own. All right, first one here, it gives us 2 triangles. And it shows us the side lengths of the triangles, right? So AB here has a side length of 10. DE has a side length of 15. So if we compare AB and DE, and they do it down here last, that's 10 over 15, right? And if we simplify 10 over 15, we get 2 over 3. So that's the ratio of one side to the next, right? 2/3, okay? If we look at another side, let's look at AC and DF, right? AC is 6, DF is 9. And look at that right here. 6 over 9, when you simplify that, you get 2/3. Imagine that. And so if we look at the third side, CB or BC and EF, that's 8 and 12. So if I write 8 over 12 and I simplify it, guess what I get? 2/3. Oh, my purple's dying. So the proportion or the ratio from one triangle, one corresponding side, to the corresponding side in another triangle is constantly the same, 2/3. For every 2 units here, there's 3 units here. For every 2 here, there's 3 here. For every 2 here, there's 3 here. It's the same ratio. So we know that these 2 triangles are similar. So we can write a similarity statement. The first triangle is similar, the little squiggle, to the second triangle. How do I know? Because of side similarity. So you're basically naming one of these 3 rules we just learned up here at the top of this paper. These notes that I fill out in every video are listed. I always attach them in the folder, so you can always print them out if you want. You are not required to, but they're there if you want them. Okay, second example, determine whether the triangles are similar, right? They can be different sizes, but they have to be proportionate. They have to be the same shape. So for this first triangle, I'm comparing this side to the second triangle, this side. And then I'm also comparing this bottom side to this bottom side. This guy, this guy, this guy, this guy. And then one thing I also notice is that between these two sides in a triangle, the angle's 70 degrees, and between the corresponding two sides in the other triangle, that's also 70 degrees, right? So it's two sides and the angle between them. Side, angle, side. So as long as these sides are proportional, meaning the ratio is the same, if the angle between them is congruent, then we know that the triangles are similar because of side, angle, side. All right, so if we compare this, NM and RQ, we get 3/4, right? That's this first one. And then NP to RS is 6/8. That's this guy. And if we cross multiply, we get the same thing. 6 times 4 is 24. 3 times 8 is 24. So these two triangles, or these two, I'm saying a mouthful, these two ratios are equal. They're the same. So whether you're talking about here to here or here to here, they're the same. And then the angle between these similar sides is congruent. So just based off side, angle, side, we know the two triangles are similar. So we can write triangle NMP is similar to triangle RQS because of side, angle, side similarity. So for every one of these, we're naming which rule we're using, okay? So let's go down here and do a few. Number 1, increase my paper. All we have here is this angle is congruent to this angle, and this guy is congruent to this guy. Is that enough to say that the two triangles are similar? Yes. Why? Because of the angle similarity rule, right? If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it says, write a similarity statement and explain your reasoning. We're going to say triangle ABC is similar to triangle DEF. Why? Because of the AA similarity. For number 3 here, we have two triangles. One is on top of overlaying the other. This smaller triangle TSL is one of our two triangles, and then the larger one TRU is the second. So we know these two triangles share the same angle right here. We also know that because of these two lines, the base of each triangle being parallel, that they're cut by a transversal, either this side or this side. So we know that either way, corresponding angles have to be congruent. 1, 2, 3, 1, 2, 3. That shows that all three angles in one triangle are congruent to all three angles in another triangle. And we didn't even need all three. We only needed 2. So we can say triangle TSL is similar to triangle TRU by the AA similarity. Okay, then below that we have number 5. We've got two sides here. This guy. And so we can say 24/16. We've got this side, 39/26. And both of the angles in between those two sides are marked congruent, right? So it looks like it's the SAS similarity rule. We just have to make sure that these two fractions are in fact equal, that they're the same proportion, right? So to do that, we can cross multiply or we can just simplify, okay? I'm actually going to simplify. So I can divide the top and the bottom of this red guy by 8. So that's going to give me 3/2. And then I can divide the green guy here, the top and the bottom, by 13. So that's also going to give me 3/2. So the ratio of corresponding sides in each triangle are similar, right? They're the same. And then the of these two sides, they're proportionate. to these two sides, and then the angle in between them is congruent, right? So this is the side angle side similarity rule, or whatever you want to call it. Triangle, let's call it BF. FEB is similar to triangle LMN, and that's by SAS Similarity. Okay, number 2. We've got, it looks like 2 right triangles here, okay? So, and then it gives us the side of each triangle on either side of that 90-degree angle. So we've got this guy, the longer of the 2 sides, 36 and 20. This is the longer of the 2. 18 and 24. This is the longer of the 2. Then we've got the shorter of the 2 and the shorter of the 2. And the angle between those 2, this one's 90 degrees and this one's also 90 degrees. So as long as the green measures here are proportional to the red measures, as long as they make up the same ratio, they're both joined, I guess, together by a congruent angle, then this would be, these 2 triangles would be similar because of the SSS similarity rule. Okay, so let's just make sure those 2 proportions are equal. So 20 over 18, I could simplify that to 10 over 9, I guess. And 36 over 24, I could simplify that to, what is that? 18 over 12, which would be 9 over 6. Which would be 3 over 2. And that's not what this is. So these would not be, these are not similar. Not similar. All right, number 4. And you will get some of those. I was confused because we were on a roll here. Like, wait, did I do something wrong? No, they're just not similar. And then number 4 here, we've got 2 sides and the angle between them. So the angle between these 2 given sides is 65. So if the 2 given sides are proportionate to each other, then we know these 2 triangles are similar because of the SAS similarity rule. 8 and 4. So it looks like 4 is half of 8. That 8 over 4 is 2. And then here, 18 and 9. And 9 is half of 18. 18 is double 9, right? So it's the same proportion. 8 is 2 of these. 4 times 2 is 8. And 18 is 2 of these. 9 times 2 is 18. And both of these, so their proportion is 2 over 1, this way and this way. And they're both joined by a 65-degree angle. So these are similar. I can say triangle DJK is similar to triangle DJK PZR by the SAS Similarity Rule. Okay, and then lastly, number 6, it looks like it gives us all 3 sides. So as long as we know that all 3 sides are proportional, then we know that these 2 triangles are similar. So out of the 3 sides, I'm going to start with the longest side. So I got 24, 32, and 40. The longest side here is, I'll do in purple, is 40. And 15, 20, and 25, the longest side is 25. 40 over 25. If I simplify that, I can divide the top and the bottom by 5, so that's 8 over 5. Then the next biggest one is 32 and 20. I can divide both of those by 4, and that's also 8 over 5. And finally, in green, I got the smallest side, 24 over 15. I can divide both of those by 3, and that gives me 8 over 5. So they're all proportional. Each side, compared to the corresponding side of the other triangle, is in a ratio 8 to 5. So this to this is 8 to 5. This to this is 8 to 5. This is 8 to 5. So all 3 sides are proportional. So we can say triangle GHI is similar to triangle QRS by SSS Similarity. Okay, if you have any questions on that, let me know, and look out for part 2 of this lesson.